Hi, and welcome to Advent of Code 2022. I'm John Eisen. This is day 18. I have done day 16 and day 17, but the videos are not posted because day 16 took me a really long time and I have to do a lot of editing, and I've been very busy. Day 17, I did post very briefly, but I realized I recorded the audio with the intro with no audio. So I took it down and I have to do some editing to pull that off. So I'll repost it in a second. This is just some troubles getting started as a creator. As you can see, I'm not at home. I'm on travel. I was traveling for a full day, like 24 hours. And so that's why I've been so busy. But I'm a bit behind. Today's actually December 19th and I'm recording day 18. But we'll get caught up. I'll do all that editing, get it posted. So let's get started. Day 18. I got multiple scenes, so let's transfer. Here we go. Day 18, boiling boulders. You and the elephants finally reach fresh air. You've emerged near the base of the large volcano that seems to be actively erupting. Fortunately, the lava seems to be flowing away from you and towards the ocean. Bits of lava are still being ejected towards you, so you're sheltering in the cavern exit a little longer. Outside the cave, you can see the lava landing in a pond and hear it loudly hissing as it solidifies. Depending on the specific compounds of the lava and speed at which it cools, it might be forming obsidian. The cooling rate should be based on the surface area of the lava droplets, so you should take a quick scan of the droplet as it flies past you. Our puzzle input. Let me just pull this mic a little closer. Okay, make sure we're getting good input. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and as a result, it approximates the shape of a lava droplet with a 1 by 1 by 1 cubes on a 3D grid, each given as an XYZ position. To approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube. So if your scan were to only have two adjacent cubes, 1, 1, 1, and 2, 1, 1, each cube would have a single side covered and 5 sides exposed. Total surface area would be 10 sides. Okay. It's doing surface area calculations. I'm going to grab this example, copy it over. Oh, we still have day 17 up, day 18, example. In the above example, so count all the surface area. Okay, this should be, actually, the problem statement in this one is reasonably simple, but our solution may not be. So let's get started. Day 18, our input is cubes. Named cube is a named tuple. Int. How do you, I already forget how to make a named tuple. Collections, it's in collections, okay. From collections, import named tuple, def parse cube, line, stir to cube, return named to, XYZ equals line.split, comma, name tuple, x equals int x, y equals int y, z equals int z. Is that how you write a named tuple? I think so. Oh no, you do it as a class, right? Class cube. This is the best way to do it. X int y int z int. Nice, okay. All right, we got our named tuple. And cubed is a list of cube. Nice, print input. Oh, I have to, sorry. I started coding and it's hidden here. So I apologize about that. I'm supposed to switch scenes. Okay, now you can see the code. All right, you can see I've written cube and parse cube. Do apologize about that. All right, let's get going again. I'm gonna run Python day 18 and on the example and get it to print the input. Okay, yep, that works. All right. So now we just have to determine each cube has 6 sides. So we just have to go through each cube and see if there's any cubes adjacent to it. And we count the number of cubes that are adjacent to it. And for every cube for every pair that's adjacent, we subtract 2 sides from our total number of sides. So surface area equals len of input.cubes times 6. And then we're slowly going to map pairwise cubes. How big is our input? Wow. Our final input is very large. Okay, my computer's a little frozen. Sorry. Okay. All right, our final input's very large. So I'm going to print some, excuse me. I'm going to print len of input.cubes. I'm going to print the min of cube.x for cube in input.cubes. And the max of that. And I just want to get an idea of how big our input is. There's 2,085 cubes, but they only go from 0 to 19. So a 20 by 20 surface area, 20 by 20 by 20, print 20 star 3, that's 8,000 units. So what we could do is create a 20 by 20 by 20 matrix, fill it with the cubes, and then go through each cube and see if how many sides are connected, and then count it that way. That would work as a solution. Pairwise, so that would be n is 8,000. We'd have O of n, or well, if n is 20, it's O of n cubed to run through and create the matrix, and then run through again to check to count surface area is O of n 2n cubed, so O of n cubed. Whereas n is 20. Another option is we could put all of these tuples in a set, go through each one, find adjacencies by looking up in the set. So that would be O of n, where n is the number of cubes, times O of log n, so O n log n, to do that because looking up in the set costs log n, and going through each cube. So 2,000 log 2,000 or O of 8,000. I guess it's faster to do O of 8,000, but I think it might be better for part 2 to do, because I'm just guessing at what part 2 is. It might be better to do the set-wise solution. So I'm going to write the set-wise solution. So let's get started. So we have cube set equals set of input.cubes for cube in input.cubes. If surface area minus equals len of adjacent cube for adjacent cube in cube.adjacent cubes if or we'll do sum, we'll do iterator, we'll do 1 if adjacent in cube set, else 0. And we'll remove these two things. And so this is nice and simple. All we have to do is write this adjacent cubes function. There's 6 sides. Whoops. Okay. Oh, yes, got to be y equals and z equals. Awesome. I think we're ready to run it. $64 is the correct answer in the example, and 3636 will be the correct answer in the example. All right, so yeah, it was very simple to write. It runs slightly longer than the other solution, but I think it might be better for part 2, so let's move on. I'm going to switch our scene back to reading. There we go. Something seems off about your calculation. The cooling rate depends on the exterior surface area, but your calculation also included the surface area of air pockets trapped in the lava droplet. Instead, consider only cube sides that could be reached by the water and stream as the lava droplet tumbles into the pond. The stream will expand to reach as much as possible, completely displacing any air outside of the lava droplet, but never expanding diagonally. Okay, wait, hold on. So we need to remove surface area that points inward. What is the exterior surface area of your scanned lava droplet? Well, the set-wise solution will not work for this. Well, it could, but it'll take too much work. What we're going to do is switch to the other solution where we put everything in a matrix and then we calculate it. So let's get started. Switching back. Okay. All right. So for part 2, we're going to create a grid. We're going to take this cube set. I think everything's 0 to 20, right? So we'll just do 0 to 20. Okay. All right, so now we have a grid of cubes, and so we need to look at every exterior surface area. So one way we can do that is we can come in from every side. So if we come in from the top, we just go down until we find something named true. We do this for every thing from the top plane. And then we do that for all 6 planes. And so if there was a single cube, we would just hit it 6 times. And then if you were offset from the cube, you would hit it 0 times. So you get 6. If there's 2 cubes, that would work. And if they contain any cubes, then that wouldn't work. So yeah, I think this is good. So our planes are when you set. So let's start with the first plane. Or def. And the question isn't whether you hit when you hit the cube, how far in. That question is only if on a line drawn, let's say x equals 0, and y equals 0, x and y equals 0. So we're just looking at the z dimension. If there are no cubes on that line, then 0 is then we add 0. If there are any cubes on that line, then we add 2, because there's come 1 from each side. And so we just have to do this for every set of x0, y0, and then every y0, and then for every number in x, y. Okay, so we can do that. And so actually what we don't want to make a grid. So I'm going to reset. We're just going to create a dictionary of planes. And we're going to represent a plane or a line as a cube where one of the lines is -1. And so we're going to create a dictionary of lines equals, and we're going to start it as empty. We're going to do 4 cube in cubes. And for each cube, we're going to set x, y, and z to -1 individually, and then set that lines, the dictionary of that cube to 1. And this will give us every line that and then when we sum all those, we'll get every line that has cubes on it, and then we just multiply that by 2, and that should be the answer, right? So lines, cube. So what we'll do is these lines are represented as just having one cube, a cube with one value set to -1. It's not the best. Ideally, we'd have another thing called a plane line, but it doesn't matter. So we just do for line in cube dot lines, lines, line equals true. And now we do sum of 2 if line, if b else 0, for b in lines dot values. All right, let's run it. It's getting a little warm because I'm on a pillow. We only got 50 for the part 2. I've got to find a better way to mount this computer. Next video. Okay. 50 is the incorrect answer. We're looking for 58, so that means we did something wrong. Let's take a look. So the only cube that is trapped within the lava droplet is 225. So there are 5 cubes on the line of x equals 2, y equals 2, z equals -1. But it doesn't matter how many cubes are on that line, so we only add 2 to get in from the top and the bottom. Oh, is it getting dark? Maybe I don't understand the answer correct, the question. I'm going to reread it. Because 225 is connected on all sides, right? So, oh, 225 is not in the puzzle, but it is trapped within the, so it's 64 minus 6. So what are we also eliminating? We have 222, 122, 322, 212, 232. So let's just print so for 2, 2, 2, we add 2, 2, negative 1, 2, negative 1, 2, negative 1, 2, 2. Still look good on video. Maybe I gotta move it. All right, there. Let me do some ordering, move up above Emacs. All right, I'm gonna stop playing around with scenes while I solve puzzles. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 13 cubes. So we add 39 lines, but they overlap. So for example, all right, we have a cube at 2, 2, 2. This means if it was just that cube, it would be hit from 6 sides. So let's do okay, yes, all right, so we add cube 2, 2, 2, and the answer is 6, right? Then we add 1, 2, 2, which is adjacent. So that means the answer is 10. Yep, and then we add 3, 2, 2, which is also adjacent. And so that means the answer is 14. That's correct, okay. And then 2, 2, 1, again, adjacent on one side. So 18, 2, 3, 2, again, adjacent on one side. 2, 22. 2, 2, 1, however, is only adjacent on one side as well. So again, add 4, 2, 2, 3, again, adjacent on one side. All right, 2, 2, 4, again, adjacent on one side. 2, 2, 6, however, 2, 2, 6 is not connected to anything, but it is on the same line as x equals 2, y equals 2. And so it is only adding, it should be adding 5. No, it doesn't add 5, it only adds 4. Yeah, okay, all right, so that's right. 1, 2, 5, adding 4. All right, we get into this 3, 2, 5, and this is where we add less than 4. So 3, 2, 5, why does 3, 2, 5 add less than 4? Because there's already something on 3, 2 at z equals 2 below it. So, but, okay, so our solution is wrong, and this is why it's wrong, is because these two cubes exist outside of the space. So they can be reached by the water, even though they wouldn't be reached by a straight line from either side. All right, so our solution is incorrect. I'm now thinking we need to rewrite it, of course. So one thing I'm thinking of is instead of calculating the amount of surface area that is on the outside, we've already calculated the total amount of surface area. Why don't we calculate the amount of surface area that's on the inside? So we look at adjacent So we can use part 1 to look at adjacent cubes. Okay, all right, we're gonna go back to the grid where we keep the 3D matrix, and then we're gonna write an algorithm that then we'll just walk all 8,000 things. And we'll count the amount of space that's available, and then we'll find all the internal things. Yeah, okay, so we're gonna go back to the grid. How are we gonna do that? I think I can just go through our deletion set. Apparently I didn't delete it correctly. So grid equals 2, 3. We're going to call part 1. We're going to remove these lines. Awesome. Excellent. Okay, so we have our grid, and then we just need to write an algorithm that walks around and finds every neighbor. We're going to use strings as a enum here, pound meaning there's a cube there, dot meaning it's empty. So how do we want to write this walking function? Okay. If grid x, y, z is equal to dot then grid x, y, z is equal to visited and then we'll call this a cube. Def get cube return grid c.x, c.y, c.z. So get c, we'll do set. Okay. For adjacent in c dot adjacent cubes. So the cube so we're just going to walk around the outside, and every time we hit a cube, we're going to add one. Yeah, and that should work. So, surface area equals 0. If get c is equal to pound, and then we just add return adjacent cubes. Elif get c is equal to pound, surface zero, return empty list 1. We don't want to be going off to infinity. Okay. That's nice and good. All right. And then don't return visited cubes. Cool. And then nodes equals cube -1, -1, -1, while len of nodes node equals node comma nodes equals node 0 node 1 by new nodes equals walk node, new surface area plus equals new surface area, nodes plus equals new nodes, return surface area. Can you guys see this? Am I blocking it? I am blocking it. Ugh, I'm sorry. Let me just do that. All right. Sorry about that. Okay. All right. So I think we're ready to try this. I'm sure it'll have some bugs, but let's run it on the example. X is not defined. Elif get G C is equal to B, return. It's already visited, we don't go it again. 58, all right. Nice. Not the right answer, too low. So we're clearly not walking everything available. Print min not Marcin cubes max. Need to make sure I'm covering the full area. Should have done this first. 0 to 19 E for each. And we're going -1 to 20, so we can always go around. Okay, we guessed 2096 before. Still getting 2096. So basically what the algorithm is that we start with a single cube at -1, -1, -1. We walk to all the adjacent cubes. So if that cube is empty, which ... is, then we just walk to all the adjacent cubes that are inside this -1 to 20 barrier. And first we set it to visited, and then so if we return after a single iteration, we have done -1, -1, -1. We've put in all of the adjacent cubes that are still in that boundary, and we have not found any cubes. And after a second round, Both are marked as visited. The thing is that when you reach a cube, you reach it from one side. And then that's marked as visited. So every time you get to an empty space, you reach a cube. We add the cube to the node list, and then when we walk there, so I guess let's do and get G C not equal to pound. And then well, I don't know what's going on. Okay, yeah, we'll do this. Still not changing the answer. 1, 2. Oh, wait a second. Wait, there's no pounds here. Oh, here are the pounds. Two, 2, 5. Two, 2, 5 should not be visited in the example. But 2, 2, 4 and 2 should be in. Two, 2, 4 should not be visited. 2, 2, 4 should be pound. Okay, we're resizing our grid. Okay. It's not going to affect anything. Okay, it looks like we don't have enough of something. Oh, right. Okay. So this should be Z. This should be X. Not a problem for the main input, but ugh. Why didn't that change? Just trying to check everything here. So we're doing Z on the outside, then Y, then X. get grid z, cz, cyx, zyx. Failed to find 300. Even though x is between 1 and 3. Oh, there it is. It's max x. There's the bug. Okay. All right. There, and now we can finally visualize the empty square. And then we can print the cube again. Using our print function up here. Yeah, and that's correct. Okay, cool. And then try it on the input. Still getting 2096. This looks good. Yeah. This was the beginning. All right, 2096 is definitely not the right answer. So we already tried it. So what are we doing wrong? Still looks like we're doing it right. Maybe we're not adding something up right. I don't know. I don't trust myself. Is that really what I answered the first time? It is. It's the same thing. All right. All right. Well, let's think about this, see what we did wrong. I'm just gonna count a bunch of things. I'm gonna stop printing the grid because that is not helping. We visited, let's do this on the example. We visited 186 cubes, 13 cubes existing in one empty space. So and all the surface area is 64, and we had a hole empty, so we get 64 minus 6. Let's do this on the input. 36 minus, we have 1,109 empty squares. They're almost all adjacent, right? So then let's do empty equals these are all the empty cubes, right? Whoops. Okay. Then adjacency surface area of empty is part 1 of input cubes equals empty, print surface area of empty. What is that? Three six minus 1534. It's 2102. That is the right answer. Huh. Okay. So what happened? Clearly our algorithm walked to every square that was possible, which is all we needed to solve the problem using this method of using part 1 again to calculate the surface area of the cubes that were not walked to, with the empty cubes in the center. However, our algorithm, like adding up all of the surface area that we hit, was incorrect. And I don't know why. If you guys know why, comment in this video. I'm going to post it. I appreciate you guys working with me while I get through all my technical issues. Hope you guys enjoy it. If you did, please like and subscribe. Let's keep doing them. Thanks. Peace.